The ground wire on a coaxial cable serves two main purposes: lightning protection and electromagnetic interference or radio frequency interference reduction. Firstly, it provides a path for lightning currents to safely dissipate into the ground, preventing damage to equipment. Secondly, it helps reduce electromagnetic interference and radio frequency interference, which can degrade signal quality. Yes, it is recommended to ground the ground wire on the coaxial cable to the metal antenna pole. This provides a direct path for lightning currents to flow into the ground. The preferred method is to use a hose clamp or screw to securely attach the ground wire to the pole. The ground wire from the coaxial cable does not need to be connected to anything at the internal end, where it connects to the television. The grounding path is established through the metal shielding of the coaxial cable itself. The shielding is connected to the ground terminal of the television or other receiving equipment. Here is how it works. When lightning strikes an antenna, the current flows through the coaxial cable and into the ground wire. The ground wire then conducts the current into the earth, effectively dissipating the energy and protecting the equipment. In normal operation, the ground wire also helps reduce electromagnetic interference or radio frequency interference by acting as a shield against electrical noise. The metal shielding of the coaxial cable is grounded, which helps to prevent external electromagnetic fields from interfering with the signal being transmitted. Grounding the coaxial cable's ground wire at the antenna pole is essential for lightning protection. While it is not necessary to connect the ground wire to anything at the internal end, the metal shielding of the coaxial cable itself provides the necessary grounding path. Let's delve deeper into the specifics of coaxial cable grounding, expanding on the initial explanation. Coaxial cable, often shortened to Coax, is a type of electrical cable that has an inner conductor surrounded by an insulating layer encased by a conductive shielding and then covered with an insulating outer jacket. This design allows it to carry high-frequency electrical signals with low loss, making it ideal for connecting antennas to receivers transmitting video signals and for broadband internet connections. The ground wire, or more accurately, the grounding conductor, plays a vital role in ensuring the safe and efficient operation of the coaxial cable system. As previously stated, its primary functions are lightning protection and the reduction of electromagnetic interference or radio frequency interference. Lightning strikes pose a significant threat to electronic equipment connected to antennas. A direct lightning strike can deliver an immense amount of energy in a very short period, causing catastrophic damage to receivers, televisions, and other connected devices. Even a nearby strike can induce a surge of voltage in the coaxial cable, which can still be harmful. The ground wire provides a low-resistance path for these currents to flow safely to the ground, diverting them away from sensitive electronics. To effectively protect against lightning, the grounding conductor must be properly connected to a grounding electrode system. This system typically consists of one or more ground rods driven into the earth, or a connection to the building's grounding system if one exists. The National Electrical Code, NEC, provides detailed requirements for grounding electrode systems, ensuring that they are capable of handling the expected fault currents. The connection between the grounding conductor and the grounding electrode system must be robust and corrosion-resistant to maintain its effectiveness over time. The NEC specifies the types of connectors and methods that are approved for grounding connections. In addition to lightning protection, the grounding conductor also plays a crucial role in reducing electromagnetic interference or radio frequency interference. Electromagnetic interference and radio frequency interference are unwanted electrical signals that can interfere with the desired signal being carried by the coaxial cable. These interference signals can originate from various sources, such as nearby electrical equipment, radio transmitters, and even atmospheric noise. The conductive shielding of the coaxial cable acts as a barrier to these interference signals, preventing them from entering the cable and disrupting the signal. However, the shielding is only effective if it is properly grounded. The grounding conductor provides a path for the interference currents to flow to the ground, preventing them from building up on the shielding and radiating into the surrounding environment. This helps to maintain the integrity of the signal and ensures that the receiver can accurately decode the information being transmitted. When installing a coaxial cable system, it is essential to follow best practices for grounding to ensure optimal performance and safety. Here are some key considerations. Firstly, always ground the grounding conductor at the antenna pole or mast. This provides the most direct path for lightning currents and interference signals to flow to the ground. Use a hose clamp or screw to securely attach the grounding conductor to the pole, ensuring a good electrical connection. Secondly, use a grounding block to connect the coaxial cable to the grounding electrode system. A grounding block is a device that provides a convenient and reliable way to connect the coaxial cable shielding and grounding conductor to the grounding system. Choose a grounding block that is rated for outdoor use and is corrosion resistant. Thirdly, keep the grounding conductor as short and straight as possible. The longer the grounding conductor, the higher its impedance, which can reduce its effectiveness. Avoid sharp bends in the grounding conductor, as these can also increase impedance. Fourthly, use appropriate connectors and fittings for all grounding connections. Use connectors and fittings that are listed for grounding applications and are compatible with the type of wire and cable being used. Ensure that all connections are tight and corrosion resistant. Fifthly, inspect the grounding system regularly to ensure that it is in good condition. Check for loose connections, corrosion, and damage to the grounding conductors and connectors. Repair or replace any damaged components immediately. At the internal end of the coaxial cable, where it connects to the television or receiver, it is generally not necessary to connect the grounding conductor to anything. The metal chassis of the television or receiver is typically grounded through the power cord, which provides a sufficient grounding path for the shielding of the coaxial cable. However, in some cases, it may be desirable to connect the grounding conductor to the grounding system at the internal end. This can be done by connecting the grounding conductor to a grounding block or a metal water pipe. This may be beneficial in situations where there is a high level of electromagnetic interference or where the television or receiver is not adequately grounded through the power cord. It is important to note that connecting the grounding conductor to the grounding system at both ends of the coaxial cable can create a ground loop. A ground loop occurs when there are multiple paths to the ground, which can cause circulating currents to flow in the grounding system. These circulating currents can create noise and interference, which can degrade the signal quality. To avoid ground loops, it is generally recommended to ground the coaxial cable at only one point, typically at the antenna pole or mast. In summary, the ground wire on a coaxial cable serves two important purposes: lightning protection and electromagnetic interference or radio frequency interference reduction. It should be grounded at the antenna pole or mast to provide a direct path for lightning currents and interference signals to flow to the ground. It is generally not necessary to connect the ground wire to anything at the internal end, as the metal chassis of the television or receiver is typically grounded through the power cord. By following best practices for grounding, you can ensure the safe and efficient operation of your coaxial cable system. Let's expand further on the principles of grounding and how they relate to coaxial cable installations. Grounding, in electrical engineering, is the process of providing a low impedance path for electrical currents to flow back to the source in the event of a fault. This path allows protective devices, such as circuit breakers and fuses, to quickly detect a fault and interrupt the current flow, preventing damage to equipment and reducing the risk of electrical shock. The concept of grounding is based on the principle that electrical current always seeks the path of least resistance. By providing a low impedance path to the ground, we can ensure that fault currents will flow safely to the ground rather than through unintended paths, such as a person touching a live wire. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding involves connecting the non-current carrying metal parts of electrical equipment to the grounding system. This includes the metal chassis of appliances, the metal enclosures of electrical panels, and the metal conduit that houses electrical wiring. The purpose of equipment grounding is to provide a low impedance path for fault currents to flow back to the source, allowing protective devices to quickly trip and energize the circuit. System grounding involves grounding one of the current carrying conductors of the electrical system, typically the neutral conductor. This is done to stabilize the voltage of the system and to provide a reference point for the voltage measurements. System grounding is typically required for AC power systems, but is not always required for DC power systems. In the context of coaxial cable installations, both equipment grounding and system grounding principles are relevant. The metal shielding of the coaxial cable is considered to be a non-current carrying metal part, and therefore it must be grounded in accordance with equipment grounding principles. The grounding conductor, which is connected to the metal shielding, provides the low impedance path for fault currents to flow back to the source. The grounding of the coaxial cable also helps to reduce electromagnetic interference or radio frequency interference, as discussed earlier. In addition to the grounding conductor, the coaxial cable itself also plays a role in grounding. The metal shielding of the coaxial cable is typically connected to the metal chassis of the television or receiver, which is grounded through the power cord. This provides a secondary grounding path for the coaxial cable and helps to ensure that the shielding is properly grounded. When installing a coaxial cable system, it is important to follow the requirements of the National Electrical Code (NEC) for grounding. The NEC provides detailed requirements for grounding electrode systems, grounding conductors, and grounding connections. It also specifies the types of connectors and fittings that are approved for grounding applications. Failure to comply with the NEC requirements for grounding can result in electrical shock hazards, equipment damage, and even fire. Here are some specific NEC requirements that are relevant to coaxial cable installations. Firstly, NEC Section 820.93 covers the grounding of coaxial cables. This section requires that coaxial cables be grounded as close as practicable to the point of entrance to the building. Secondly, NEC Section 820.100 covers the bonding of coaxial cable shields. This section requires that the shields of all coaxial cables entering a building be bonded together to form a common grounding point. Thirdly, NEC Section 250 covers the general requirements for grounding and bonding. This section provides detailed requirements for grounding electrode systems, grounding conductors, and grounding connections. In addition to the NEC requirements, there are also some best practices that should be followed when installing a coaxial cable system. Firstly, use high-quality coaxial cable that is properly shielded. The shielding of the coaxial cable is the primary barrier against electromagnetic interference or radio frequency interference, so it is important to use cable that has good shielding characteristics. Secondly, use high-quality connectors and fittings. The connectors and fittings are the points where the coaxial cable is most vulnerable to signal loss and interference, so it is important to use connectors and fittings that are properly designed and installed. Thirdly, avoid running coaxial cables near sources of electromagnetic interference or radio frequency interference. Sources of interference include electrical equipment, radio transmitters, and fluorescent lights. If possible, run the coaxial cables in a separate conduit or raceway to shield them from interference. Fourthly, test the coaxial cable system after installation to ensure that it is working properly. Use a cable tester to check the signal strength, signal quality, and impedance of the coaxial cable. This will help to identify any problems with the installation before they cause problems with the television or receiver. By following these best practices, you can ensure that your coaxial cable system is properly grounded and that it provides a high-quality signal to your television or receiver. Now, let's further elaborate on the practical aspects of grounding a coaxial cable for an antenna, considering various scenarios and providing more detailed guidance. Grounding a coaxial cable for an antenna is essential for safety and performance. As previously mentioned, it protects against lightning strikes and reduces electromagnetic interference or radio frequency interference. However, the specific grounding method may vary depending on the type of antenna, the location of the antenna, and the grounding system available. Firstly, consider the type of antenna. There are two main types of antennas: outdoor antennas and indoor antennas. Outdoor antennas, such as rooftop antennas and satellite dishes, are more exposed to lightning strikes and electromagnetic interference or radio frequency interference than indoor antennas. Therefore, outdoor antennas require more robust grounding systems. Indoor antennas, such as those used for over-the-air television reception, are typically less exposed to lightning strikes and electromagnetic interference or radio frequency interference. However, it is still important to ground the coaxial cable for safety reasons. Secondly, consider the location of the antenna. Antennas that are located in areas with high lightning activity or high levels of electromagnetic interference or radio frequency interference require more robust grounding systems. For example, an antenna located on a hilltop or near a radio transmitter may require a dedicated grounding rod and a heavy-gauge grounding conductor. Antennas that are located in areas with low lightning activity or low levels of electromagnetic interference or radio frequency interference may be able to use a simpler grounding system, such as a connection to the building's grounding system. Thirdly, consider the grounding system available. If the building has a well-established grounding system, it may be possible to connect the coaxial cable to the building's grounding system. However, it is important to ensure that the building's grounding system is adequate for the antenna installation. If the building does not have a well-established grounding system, it may be necessary to install a dedicated grounding rod for the antenna. A dedicated grounding rod should be at least 8 feet long and should be driven into the ground as close as possible to the antenna. The grounding conductor should be connected to the grounding rod using a grounding clamp that is listed for direct burial. When connecting the coaxial cable to the grounding system, it is important to use a grounding block. A grounding block is a device that provides a convenient and reliable way to connect the coaxial cable shielding and grounding conductor to the grounding system. Choose a grounding block that is rated for outdoor use and is corrosion resistant. The grounding block should be mounted as close as possible to the point where the coaxial cable enters the building. The grounding conductor should be connected to the grounding block using a grounding lug or screw. The grounding conductor should be as short and straight as possible. Avoid sharp bends in the grounding conductor, as these can increase impedance. If the coaxial cable is longer than 20 feet, it may be necessary to install a second grounding block at the midpoint of the cable. This will help to reduce the impedance of the grounding system and improve its effectiveness. When installing a coaxial cable system, it is important to follow the requirements of the National Electrical Code (NEC) for grounding. The NEC provides detailed requirements for grounding electrode systems, grounding conductors, and grounding connections. It also specifies the types of connectors and fittings that are approved for grounding applications. Failure to comply with the NEC requirements for grounding can result in electrical shock hazards, equipment damage, and even fire. In addition to the NEC requirements, there are also some best practices that should be followed when installing a coaxial cable system. Firstly, use high-quality coaxial cable that is properly shielded. The shielding of the coaxial cable is the primary barrier against electromagnetic interference or radio frequency interference, so it is important to use cable that has good shielding characteristics. Secondly, use high-quality connectors and fittings. The connectors and fittings are the points where the coaxial cable is most vulnerable to signal loss and interference, so it is important to use connectors and fittings that are properly designed and installed. Thirdly, avoid running coaxial cables near sources of electromagnetic interference or radio frequency interference. Sources of interference include electrical equipment, radio transmitters, and fluorescent lights. If possible, run the coaxial cables in a separate conduit or raceway to shield them from interference. Fourthly, test the coaxial cable system after installation to ensure that it is working properly. Use a cable tester to check the signal strength, signal quality, and impedance of the coaxial cable. This will help to identify any problems with the installation before they cause problems with the television or receiver. By following these best practices, you can ensure that your coaxial cable system is properly grounded and that it provides a high-quality signal to your television or receiver. Let's delve into the potential issues that can arise from improper grounding of coaxial cables, along with troubleshooting tips and preventative measures. Improper grounding of coaxial cables can lead to a variety of problems, ranging from minor signal degradation to serious safety hazards. Here are some of the most common issues. Firstly, electrical shock hazard. If the coaxial cable is not properly grounded, it can become energized in the event of a lightning strike or other electrical fault. This can create a serious electrical shock hazard for anyone who comes into contact with the cable or connected equipment. Secondly, equipment damage. Lightning strikes and electrical surges can damage or destroy electronic equipment connected to the coaxial cable. This can include televisions, receivers, and other devices. Thirdly, signal degradation. Improper grounding can introduce noise and interference into the signal, which can degrade the picture and sound quality of the television or receiver. Fourthly, ground loops. Ground loops occur when there are multiple paths to the ground, which can cause circulating currents to flow in the grounding system. These circulating currents can create noise and interference, which can degrade the signal quality. Fifthly, corrosion. Improper grounding can accelerate corrosion of the coaxial cable and connectors, which can lead to signal loss and equipment failure. To troubleshoot problems related to improper grounding, here are some tips. Firstly, check the grounding connections. Ensure that all grounding connections are tight and corrosion-free. Use a wire brush to clean any corroded connections. Secondly, test the grounding system. Use a multimeter to test the resistance of the grounding system. The resistance should be as low as possible, ideally less than 5 ohms. Thirdly, check for ground loops. Disconnect the coaxial cable from the television or receiver and use a multimeter to check for voltage between the coaxial cable shield and the grounding system. If there is voltage present, there is a ground loop. Fourthly, inspect the coaxial cable. Look for any signs of damage to the coaxial cable, such as cuts, cracks, or corrosion. Replace any damaged cable. To prevent problems related to improper grounding, here are some preventative measures. Firstly, use high-quality coaxial cable and connectors. High-quality cable and connectors are more resistant to corrosion and signal loss. Secondly, follow the NEC requirements for grounding. The NEC provides detailed requirements for grounding electrode systems, grounding conductors, and grounding connections. Thirdly, install a surge protector. A surge protector can protect electronic equipment from damage caused by lightning strikes and electrical surges. Fourthly, inspect the grounding system regularly. Check the grounding connections for tightness and corrosion. Test the resistance of the grounding system to ensure that it is still effective. Fifthly, hire a qualified electrician. If you are not comfortable working with electrical systems, hire a qualified electrician to install and maintain your coaxial cable system. Let's now discuss the specific tools and materials needed for proper coaxial cable grounding, providing a practical guide for those undertaking the installation. Properly grounding a coaxial cable system requires the right tools and materials to ensure a safe and effective installation. Here is a comprehensive list of what you'll need. Firstly, coaxial cable. Use high-quality coaxial cable with a solid copper center conductor and a braided shield. RG6 cable is commonly used for antenna installations. Secondly, grounding block. Choose a grounding block that is rated for outdoor use and is corrosion resistant. The grounding block should have a solid metal construction and a secure connection for the grounding conductor. Thirdly, grounding conductor. Use a copper grounding conductor that is sized appropriately for the application. A 10 American wire gauge, AUG, copper wire is typically sufficient for most antenna installations. Fourthly, grounding rod. If the building does not have a well-established grounding system, you will need to install a dedicated grounding rod. The grounding rod should be at least 8 feet long and should be made of copper or copper-clad steel. Fifthly, grounding clamp. Use a grounding clamp that is listed for direct burial to connect the grounding conductor to the grounding rod. The grounding clamp should be made of corrosion-resistant material, such as bronze or stainless steel. Sixthly, connectors. Use high-quality connectors that are designed for use with coaxial cable. F connectors are commonly used for antenna installations. Seventhly, tools. You will need a variety of tools to install the coaxial cable system, including a wire stripper, a crimping tool, a screwdriver or wrench, and a hammer. Eighthly, multimeter. A multimeter is used to test the grounding system and check for voltage between the coaxial cable shield and the grounding system. Ninthly, safety equipment. Always wear safety glasses and gloves when working with electrical systems. Here's a more detailed look at some of the key components. Coaxial cable. Choice of coaxial cable is crucial for signal quality and grounding effectiveness. RG6 cable is a popular choice due to its low signal loss and good shielding properties. Ensure that the cable is rated for outdoor use if it will be exposed to the element. Grounding block. The grounding block serves as the central point for connecting the coaxial cable to the grounding system. It typically has F connector terminals for the coaxial cable and a lug or screw for connecting the grounding conductor. Choose a grounding block that is made of corrosion-resistant materials such as brass or stainless steel to ensure long-term reliability. Grounding conductor. The grounding conductor provides the path for fault currents to flow to the ground. Copper wire is the preferred material for grounding conductors due to its low resistance and good conductivity. The size of the grounding conductor should be determined based on the size of the coaxial cable and the grounding requirements of the NEC. Grounding rod. A grounding rod is a metal rod that is driven into the ground to provide a low impedance connection to the earth. Grounding rods are typically made of copper or copper-clad steel and should be at least 8 feet long. The grounding rod should be installed as close as possible to the antenna and should be driven into the ground until the top of the rod is below the surface. Connectors. Connectors are used to terminate the ends of the coaxial cable and connect it to the grounding block, antenna, and other equipment. F connectors are the most common type of connector used for antenna installations. Use high-quality connectors that are properly crimped to ensure a secure and reliable connection. Tools. A variety of tools are needed to install the coaxial cable system, including a wire stripper, a crimping tool, a screwdriver, a wrench, and a hammer. A wire stripper is used to remove the insulation from the coaxial cable without damaging the center conductor or the shield. A crimping tool is used to crimp the connectors onto the coaxial cable. A screwdriver and wrench are used to tighten the screws and bolts in the grounding block, antenna, and other equipment. A hammer is used to drive the grounding rod into the ground. Multimeter. A multimeter is an essential tool for testing the grounding system and checking for voltage between the coaxial cable shield and the grounding system. A multimeter can be used to measure the resistance of the grounding system and to check for ground loops. Safety equipment. Safety is paramount when working with electrical systems. Always wear safety glasses to protect your eyes from debris and wire clippings. Wear gloves to protect your hands from electrical shock and cuts. By using the right tools and materials, you can ensure that your coaxial cable system is properly grounded and that it provides a safe and reliable connection for your antenna. Finally, let's examine common misconceptions about coaxial cable grounding, aiming to dispel myths and reinforce accurate understanding. There are several common misconceptions about coaxial cable grounding that can lead to improper installations and potential safety hazards. It's crucial to understand the facts to ensure a safe and effective grounding system. Firstly, misconception 1: grounding is not necessary for indoor antennas. Fact: even though indoor antennas are less exposed to lightning strikes, grounding is still important for safety. A surge from the power line or other electrical fault can still travel through the coaxial cable and damage equipment or create a shock hazard. Secondly, misconception 2: connecting the coaxial cable to a metal water pipe is sufficient grounding. Fact: while a metal water pipe can provide a grounding path, it is not always a reliable one. Plastic pipes or breaks in the metal pipe can interrupt the grounding path. A dedicated grounding rod is the preferred method for grounding coaxial cables. Thirdly, misconception 3: the grounding conductor can be any type of wire. Fact: the grounding conductor must be made of copper and must be sized appropriately for the application. A smaller wire may not be able to handle the fault current in the event of a lightning strike or electrical fault. Fourthly, misconception 4: the grounding clamp can be installed anywhere on the grounding rod. Fact: the grounding clamp should be installed as close as possible to the top of the grounding rod to ensure a good electrical connection. Fifthly, misconception 5: it's okay to have multiple grounding points for the coaxial cable. Fact: multiple grounding points can create ground loops, which can introduce noise and interference into the signal. The coaxial cable should be grounded at only one point, typically at the grounding block near the antenna. Sixthly, misconception 6. A surge protector is a substitute for proper grounding. Fact: a surge protector can help to protect equipment from damage caused by lightning strikes and electrical surges, but it is not a substitute for proper grounding. A surge protector works by diverting the surge to the ground, so it still relies on a properly grounded system to be effective. Seventhly, misconception 7. You can ground the coaxial cable by connecting it to the neutral wire in the electrical panel. Fact: connecting the coaxial cable to the neutral wire is dangerous and can create a shock hazard. The neutral wire is a current-carrying conductor and should not be used for grounding purposes. Eighthly, misconception 8. If you have cable television, you don't need to ground your antenna. Fact: even if you have cable television, you should still ground your antenna if you have one. The antenna can still be struck by lightning or experience electrical faults, even if it is not being used to receive television signals. Ninthly, misconception 9. You can use the same grounding rod for multiple antennas. Fact: it is generally recommended to use a separate grounding rod for each antenna to minimize the risk of ground loops and interference. Tenthly, misconception 10. If everything seems to be working fine, then the grounding must be okay. Fact: even if you are not experiencing any problems with your television or receiver, it is still important to inspect the grounding system to ensure that it is properly installed and maintained. A faulty grounding system may not cause any noticeable problems until there is a lightning strike or electrical fault. By understanding these common misconceptions, you can avoid mistakes and ensure that your coaxial cable system is properly grounded for safety and performance. Remember, proper grounding is not just about improving signal quality, it's about protecting your equipment and your safety. Always follow the requirements of the National Electrical Code, NEC, and consult with a qualified electrician if you have any questions or concerns.